Down there, life continues. The traffic.
Good day, grade 8 learners. Welcome to today's Natural Sciences lesson. My name is Patuchezo Singo, and this lesson is proudly brought to you by the Gauteng Department of Education. In today's lesson, we are going to be learning under the knowledge area, energy and change. The topic is static electricity, and the subtopic, which is our main area of focus in today's lesson, is friction and static electricity. Now, let's go through the lesson objectives and find out our goals for today's lesson. So these are the goals we want to achieve by the end of today's lesson. So at the end of today's lesson, you should be able to define friction, define static electricity, describe electrostatic discharge, investigate static electricity, describe the structure of an atom, and explain what a neutral atom is, as well as explain how a material becomes electrically charged. All this is sourced from your CAPS document from page 47 to page 48. All right, now let's take a trip down memory lane. To lay down the foundation for this lesson, we were introduced to circuits and current electricity in grade 5 and in grade 6, if you remember. Now, let's do our baseline activity. So I'm going to read out the questions for you and then give you time to answer them. So the first question reads right. Study the diagram below and answer the questions. The first question, how many electrons does this atom have? Number 2, what is the atomic number of the atom? And then number 3, what is the charge of this atom? Explain your answer. Take 3 minutes to quickly answer all these 3 questions. Don't forget to send in any questions you may have to our WhatsApp line, which is 079-578-2908. Also, send in pictures of your solutions of this baseline activity. See you after 3 minutes. Welcome back, learners. Now let's answer the questions together. So you are required to study the diagram and answer the question. So the diagram shows an atom with our keys there, electron for the red circles, the blue circles are the protons, and the orange circles represent neutrons. So the first question read, how many electrons does this atom have? So which ones are the electrons? The electrons are the small red circles. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8. So this atom has 8 electrons. This atom has 8 electrons. The second question read, what is the atomic number of the atom? Do you remember what the atomic number is? The atomic number is the number of protons. So let's count the number of protons that this atom has. 1, 2, 3, 4, 5, 6, 7, 8. So the atomic number is 8. The third question, what is the charge of this atom and explain your answer? The charge of this atom is neutral. Why are we saying it is neutral? Because in a neutral atom, the number of electrons and the number of protons are always equal. And in this case, we know that the number of electrons is 8 and the number of protons is also 8. So this atom is a neutral atom. So that is the charge. The charge is neutral. The explanation is the number of electrons in a neutral atom is always equal to the number of protons. Therefore, an atom as a whole is electrically neutral. Take 1 minute to quickly copy down the corrections, then see you after 1 minute. Welcome back, learners. I hope you copied down the corrections. Don't forget to send in any questions you may have pertaining this lesson to our WhatsApp number 079 578 2908. Now, let us learn a few terms. So these terms are very important because they'll help us to better understand the concepts that are being taught in today's lesson. So the first term is friction. The first term is friction. What is friction? Friction is the force that opposes the relative motion between two surfaces of objects when they come into contact. The second term is electric charge. Electric charge, this is the positive or negative property of a particle, the positive or negative property of a particle. The next term is static electricity. Static electricity, it is an electrical charge that is caused by the buildup of charges on the surface of an insulator of electricity. On the surface of an insulator of electricity. Let's go to the second slide. Attract. Attract, it means to make something move towards another thing. To make something move towards another thing. The next one is repel, means to push away from something. To repel is to push away from something. Insulator. Insulator, if you remember from term 2, we learned that non-metals are insulators. Now, an insulator is a material that does not allow charge to flow through it. Neutral Neutral, an object that has the same number of positive and negative charges. Electric discharge. Electric discharge, it is the release of electric charge through a solid, liquid, or gas. Through a solid, liquid, or gas. Now, let us recap on the structure of an atom. Let us recap on the structure of an atom. Now, atoms, we know that they are made up of subatomic particles. And how many other subatomic particles do you remember? There are 3 of them. Now, let us name them. The first one is positively charged protons. Positively charged protons. Next, we've got neutral neutrons that are tightly packed in the nucleus. And then the third subatomic particle, these are negatively charged electrons that orbit freely around the nucleus. Then a neutral atom, let's go back to a neutral atom. It has an equal number of negatively and positively charged particles. So there is the structure of an atom. So which part is referred to as the nucleus? So this is the nuclear region. And the particles that we find in the nuclear region, or rather the subatomic particles that we find within the nuclear region, are the protons and the neutrons. We find them here tightly packed. Then outside of the nucleus are the electrons that we see here freely orbiting around the nucleus. Okay, so the electrons can move or can be lost or can be gained because they are not tightly packed in the nucleus. Protons, however, and neutrons do not move. They do not move out of the atom. Now let us learn about friction. So we have defined friction in our terminology. Now let's learn more about it. Again, friction is the force. So it is a force that opposes the relative motion between 2 surfaces of objects when they come into contact. So when there is a force that opposes the relative motion that occurs between 2 surfaces of object, we call that friction. Now, friction has an effect. It has an effect. It causes electrons to move from one object to another. Remember, I said protons cannot move from an atom. They cannot be lost from an atom because they are tightly packed in the nucleus. Electrons, however, can be moved from one object to another through the process of friction. Now, when this movement happens, remember it's 2 surfaces of objects. So when this friction happens, one object is going to gain electrons, because remember, friction causes electrons to move. So the object that gains electrons becomes negatively charged. Why do we say it becomes negatively charged? It becomes negatively charged because now it has more electrons than protons. Remember, electrons are negatively charged and protons are positively charged. Now, an atom is said to be neutral when the number of negative charges and the number of positive charges are equal. So when we have a situation where we now have more negative charges than positive charges, we now say that this object has become negatively charged. The object that loses electrons. So when friction happens, one object loses electrons and the other one gains electrons. So when that object that loses electrons becomes positively charged. Why do we say it becomes positively charged? Because now the pluses or the positive charges are now more than the negative charges. So the object that loses electrons becomes positively charged. So here we have a typical example of an act of friction where we've got a ruler and we've got a cloth and they're rubbing against each other. One loses electrons and the other one gains those electrons that would have been lost. Now, electrons are never created or destroyed. They can only be transferred from one object to another. What does this statement mean? This statement means the number of electrons that one object loses is the same number of electrons that the other object is going to gain. So if object A loses 5 electrons, which means object B would have gained 5 electrons. Now, insulators can only become electrically charged through friction because they do not conduct electricity. Remember when we were learning about different types of materials and properties of different materials? We've got your insulators and we've got your conductors. We know that insulators do not conduct electricity, but they can become electrically charged through friction. They do not conduct electricity. What does conduct electricity mean? They don't allow electrical charges to flow through them, but they can hold a charge. They are able to hold a charge. So we say they can become electrically charged. They can become electrically charged. So let's go back to the point of electrons can never be created nor destroyed. So I've got an illustration here to further explain what I mean. So we've got object A here and we've got object B. So these two are neutral. Why are we saying they are neutral? Because the number of negative charges is equal to the number of positive charges in each object. Let's count it and prove it. 1, 2, 3, 4, 5, 6. So we've got 6 negative charges. 1, 2, 3, 4, 5, 6. So we've got 6 positive charges. So these two objects, each of them has a neutral charge. But through the process of friction, rubbing them together, through the process of friction, one object gains electrons, that is object B, and then one object loses electrons, that is object A. So object A, the one that has lost electrons, now has 1, 2, 3 electrons, and 1, 2, 3, 4, 5, 6 protons. So it is now positively charged. Object B gained those 3. Let's prove and see. So object A, we know that it had 6 electrons. Now it has 3, which means 6 minus 3, it lost 3. So object B should have gained 3 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 means from the 6 we added 3 and now we have 9. So object B has gained. So the number of electrons that one object loses is the same number of electrons that another object gains. Now let's learn more about static electricity. So now the imbalance that occurs between negative and positive charges in an atom is called static electricity. So that losing of electrons causes an imbalance between the positive and negative charges. That gaining of electrons also causes an imbalance between the positive and negative charges. And what do we call it? We call it static electricity. Static electricity. Now, let's look at an example between the ruler and a soft cloth. The ruler on its own and the soft cloth on its own, these two are neutral. And when you hear the word neutral, what does that mean to you? It means the number of positive charges and negative charges are equal. So when the ruler is rubbed with the soft cloth, there is a force of friction between the ruler and the soft cloth. And now we know what friction causes. Friction causes a loss of electrons and gaining of electrons. Now this, because of friction, we said friction is the force that opposes. Now the soft cloth will resist the movement of the ruler. And by resisting the movement of the ruler, it causes the outer electrons of the atoms of the soft cloth to be transferred to the ruler. And the positive protons do not move. Why? They are tightly packed in the nuclear region. They are held tightly in the nucleus of the atom, so they're not going to move. So because the soft cloth's electrons have been transferred to the ruler, we say the soft cloth has lost electrons. And the object that loses electrons becomes positively charged because now the positive charges outnumber the negative charges. So it has fewer electrons than protons. The ruler gains electrons. It gains electrons, which causes it to have a charged surface. And what is that charge? It is negative because now the electrons, they are coming from the electrons have been gained. The soft cloth lost electrons and the ruler gained electrons. So now it has more electrons than protons. So the ruler has a negative charge. It has a negative charge after this act of friction that has happened. It has a negative charge. So the number of electrons that the soft cloth has lost, remember, is equal to the number of electrons that the ruler has gained. Remember, electrons can never be created and they can never be destroyed. They can be transferred from one object to another. So the exact number of electrons that the soft cloth has lost is equal to the exact number of electrons that the ruler would have gained. Both, in this particular case, both the soft cloth and the ruler, we know them as insulators. Insulators are non-conductors of electricity. They cannot conduct electricity. So what happens to the charges then? The charges are going to remain static on their surfaces. The charges are going to remain static on their surfaces. And that negative buildup on the surface of the ruler, remember the ruler gained electrons and became negatively charged. It remains static. So through friction, we are able to charge different materials, especially your glass, plastic, nylon, and wool. All these are insulators, but through friction, they can be charged. They can be charged or they can become electrically charged. Which brings us to our first activity. I'm going to read out the questions and then give you time to answer the questions. Don't forget to send in your solutions to our WhatsApp number 079-578-2908. Question 1. How do electrons move from one object to another? Question 2. What is static electricity? Question 3. What charges move when objects are rubbed against each other? Question 4. What is the electric charge of an object that loses electrons? Give yourself 4 minutes to quickly answer these questions. Then after 4 minutes, we are going to do the solutions together. See you after 4 minutes. Welcome back, learners. Let's answer these 4 questions together. How do electrons move from one object to another? Electrons move from one object to another through friction. What is static electricity? It is an electrical charge caused by the buildup of electric charges on the surface of an insulator. What charges move when objects are rubbed against each other? It is the negative charges. Those are the ones that move. And what is the electric charge of an object that loses electrons? That loses electrons, the object will become positively charged. Take 2 minutes to quickly copy down the corrections, and then after 2 minutes, we will continue with our lesson. Welcome back, learners. Now let's move on. So we're going to be learning about the effect of charged objects on each other. So an object becomes electrically charged when it is rubbed against another object, and this is through friction. So this charge can either be positive or negative depending on which object has gained electrons and which object has lost electrons. Now, a charged object has the ability to influence other charged or neutral objects. So it can influence another charged object, and it can also influence neutral objects. Now, objects that have different electric charges will attract each other. So they will come towards each other, they will move towards each other if they have charges that are different. What are different charges? If one has a positive charge and the other one has a negative charge, they will move closer to each other. So let's look at this picture here. So we've got object A and object B. So through the process of friction, they became electrically charged. One lost electrons and became positively charged. The other one gains electrons and becomes negatively charged. So now that these two have different charges, they will be attracted to each other, meaning they're moving closer to each other. As you can see, object A and object B are now closer to each other. So what happens if the opposite happens? Okay, so objects that have the same charges repel each other, meaning they move away from each other, they move away, they push away from each other. Repulsion is the tendency of objects that have the same electric charge to move away from each other. So to repel is actually the process of repulsion. So Electrostatic charges are obtained when the weather is dry, when there is no humidity. When it's dry, that's when you best get your electrostatic charges. So I've got some illustration here to further explain what I mean by like charges, repelling, the same charges, attracting. So this is repulsion. We are seeing repulsion here because we've got like charges. We've got a negative charge here and a negative charge here. So they are going to move further apart from each other. Here, next, there's also some repulsion that is being exhibited here because we've got like charges. The charges are the same. This ball is positively charged and the second ball is also positively charged. So they will move away from each other. Then, no attraction, no repulsion. These are two neutral balls. They have no charge. They are both neutral. And then attraction happens between like charges. So they will come closer to each other. Sorry, from opposite charges. This one is a negative charged ball. This one is a positive charged ball. So they will move towards each other. They will attract. They will attract. Now let's learn about electric discharge. Let's learn about electric discharge. So we know already. What do we know? We know that static electricity is the buildup of charges on the surface of an object. And that object is usually a non-conductor of electricity, which is an insulator. It could be your glass, plastic, ceramics, rubber, wood, wool, fabric, paper, cork. So static electricity is the buildup of electric charges on an insulator. Now the charges, they stay there. They remain static on the surface of the object. Let's say this paper has become static, so the charges are going to remain static on the surface of that particular object. Why? Because they are not moving. Remember, insulators, they are non-conductors of electricity, so they cannot allow electric charges to flow through them. So the charges are going to remain static on the surface of the insulator. So when there are too many charges on the surface of the object, the charges have a tendency to move to either a neutral object, so a neutral object, one which has equal negative and positive charges, or a positive object which has an imbalance between the positive and the negative charges, having the positive charges being more. And this process is called electric discharge. Now, electric discharge now is the release of electrons through a solid, a liquid, or a gas. So this insulator, it could be a rubber band, a solid rubber band, it could be a liquid, or it could be a gas. Now, this discharging occurs when objects touch each other or when the charged object is brought near another object. It could be the neutral object or it could be the positively charged object. So this is when discharging happens, either when when a charged object touches a neutral or a positively charged object, or it is brought near So what happens when this discharge, or what are the effects of this discharge? So a discharge can cause sparks. So if you're in the dark under the blankets and there happens to be a discharge, you're going to see a spark, or you're going to feel a slight shock of electricity, especially if that air is quite dry. I'm sure you have experienced it before. Maybe you touch your friend and you feel a slight shock. That is an effect of electric discharge. So here are some electric discharge examples that are there in nature. Although some of these sparks of static electricity are harmless, your friend touches you, you feel a slight shock, are harmless, and electric discharge can also be dangerous and quite fatal. Lightning, for example, is an example of an electric discharge. That is caused by the buildup of static electricity in the clouds. So lightning is one example of electric discharge when we've got buildup of static electricity up there in the clouds, and then there is a discharge all the way down to earth. to try and reduce some of those negative charges. We also have another example where electric discharge is known to happen in industry. So in industry, especially in the trucking business, where they are carrying lots of loads, they are moving petroleum, they are moving different kinds of liquid and dry products, electrostatic charges are known to build up. So without proper grounding, this is quite dangerous. So what engineers do is they add chains or these metal hooks to the truck, so that when there is when the product is loaded onto the truck and then charges build up, when the truck stops, those charges can simply be discharged by having one of these chains touch the earth. One of these chains touch the earth, then we'll have electric discharge, and all these charges that would have built up during the loading or the transferring of the liquid goods or of the dry goods into the truck will then be transferred onto the earth in a safe manner. In a very safe manner, to prevent accidents, especially if the truck is carrying fuel, to prevent accidents in case there is a spark during the electric discharge. Now, let's move on to our second activity. So our second activity has 5 questions. So the first question reads, how does a charged object affect another charged object? Number 2, what is an electrostatic discharge? Number 3, what is the result of a discharge of electrons? Number 4, what will happen when you are electrically charged and you touch your friend? Number 5, what does your friend experience when you touch him or her? Take 5 minutes to do this activity, and then after 5 minutes, we will do the solutions together. Welcome back, learners. Now let's answer the questions together. We'll start off with the first three questions. How does a charged object affect another charged object? It can attract or repel another charged object. It can attract it if the other charged object has a different charge, or it can repel it if the other charged object has the same charge or a like charge. Okay. Number two, what is an electrostatic discharge? It is the flow of electrons from a charged object to a neutral or a positive object. So that is what it is. Number three, what is the result of a discharge of electrons? They could be a spark or a shock. A spark or a shock. If in the case of lightning, you see that big lightning bolt. In the case of a discharge between you, maybe you're under the covers, you see just a slight spark. And if you touch someone and there is electric discharge that happens, you feel a shock. Take 2 minutes to quickly copy down these three, and then we'll continue with our revision in the next slide. Welcome back, learners. Now let's answer question 4 and question 5. Question 4. What will happen when you are electrically charged and you touch your friend? What will happen is there will be an electrical discharge to the friend. So the friend might see a spark, as if you're in the dark, and or they can feel a slight shock. Number 5. What does your friend experience? The friend will experience a slight shock and might see a spark. All right. So after, we are going to take 1 minute to copy down the corrections, and then afterwards we are going to the lab to investigate static electricity. So take 1 minute to quickly copy down the corrections, and then join me in the lab as we investigate static electricity.
And now, grade 8 learners, we're going to do today's experiment. So let's find out what the aim of the experiment is. So the aim of the experiment is to investigate friction and static electricity. What is the hypothesis? The hypothesis is friction between a balloon and wool causes static electricity, which causes papers to stick to the side of the balloon. And what are we going to use? We're going to use a balloon that has been filled with air, and we're going to use small pieces of paper. So there is the balloon and there are the small pieces of paper. So what is the method that we're going to follow? What are the steps that we're going to follow? So here we go. Here is the method. First, we need to take a balloon full of air. Hold the balloon a short distance away from your pieces of paper, and then you need to record what you notice. So after that, number 3, rub the balloon against the wool, and now hold the balloon a short distance away from the pieces of paper. And there's a follow-up question. What do you see? What do you see? Okay, so now let us do the experiment together. Okay, so we have here our balloon that is full of air. I've blown air into the balloon and tied it at the end to make sure that we secure the air inside. And then I cut out pieces of paper and put them here on the table. So remember, the first step read, bring the balloon close to the pieces of paper, and what do you see? There we go. Nothing is happening between the balloon and the pieces of paper. So next, I'm wearing a woolen jersey. So what I'm going to do is I'm going to just pull my lab coat back a bit. Right there, exposing the part of the wool that I'm wearing. Then I'm going to take the balloon, rub it on the wool. Rub the balloon on the wool. Remember the name of this process? It is called friction. It is called friction. What's the next step? The next step is to bring the balloon close to the pieces of paper. What can you see? What can you see? There we go. What do you see? What do you see? There we go. As we bring the balloon close to the pieces of paper, what do you see? Okay, so now that we are done with our experiment, let's move on to the experimental questions. The experimental questions are going to help us further discuss what we saw are the results or our observations, and then they'll help us to come to a conclusion. So now let us move on to the experimental questions.
Welcome back, learners. I hope you enjoyed our short investigation of static electricity. So now we need to answer a few experimental questions so that we know what we observed and what we concluded from that. So the first question is, what did you do to make the pieces of paper stick to the balloon? Number 2, do you understand why the paper rises and is attracted to the balloon after you rub the balloon on the wool? Explain. Take 3 minutes to answer these 2 questions, and then after that, we will wrap up our lesson. Welcome back, learners. Now let's answer these two experimental questions. So what did you do to make the pieces of paper stick to the balloon? Rubbing the balloon on wool, as you saw me rubbing it on my jersey. You can also answer and say creating friction. Number two, do you understand why the paper rises and is attracted to the balloon after you rub the balloon on the wool? Explain. So when the balloon is brought near the pieces of paper, the paper is attracted to the negatively charged balloon, resulting in the paper sticking to the balloon. Take 1 minute to quickly copy down these two, and then after that, we'll wrap up our lesson. Welcome back, learners. Let's wrap up our lesson. So today we learned about friction, and that friction can cause the buildup of electric charges on the surface of objects. We also learned that the imbalance that occurs between negative and positive charges in an atom is called static electricity. We also learned that electrons are capable of movement. They can move from one material to another, causing some materials to be negatively charged and others to be positively charged. And we also learned that unlike charges will attract, so charges that are different, positive and negative charges will attract, and like charges will repel each other. The discharge of electrons can cause these results. It can cause shocks and sparks of static electricity. Now, let's move on. Now, please do remember to send in any questions or answers to any solutions that you may have written down during the course of our lesson on our WhatsApp line. Now, let's write down the homework activity. So, take 1 minute to quickly copy down the homework activity. Welcome back, learners. In our next lesson, we are going to learn about circuits and current electricity. Thank you so much for joining me in today's lesson. I hope you thoroughly enjoyed it. See you in the next one. Bye-bye.